Hello everyone, my name is Michalis Papakostas. I'm a postdoctoral researcher at the University of Michigan, and in this work we are dealing with the problems of detecting driver drowsiness and distractions. The main goals of these projects include the creation of a multimodal dataset for addressing the aforementioned driving conditions, the exploration of how drowsiness and distracted behaviors can overlap and how different modalities can help towards detecting and distinguishing the two conditions, the identification of specific multimodal features indicative of the two driver states, and the development of personalized driver models. This exploration aims to help us understand which modalities are valuable towards detecting various informative behavioral signals from the drivers and explore how different types of distractors affect drivers' behavior. For these experiments, we collected in total 12 different modalities from 45 subjects. In particular, we collected data from 3 different RGB cameras of varying qualities capturing multiple points of view, an infrared camera, 4 physiological indicators, namely skin temperature, skin conductance, blood volume pulse, and respiration, 2 thermal camera recordings of different qualities capturing different points of view, plus audio and transcripts from all the verbal interactions that took place during the data collection. The experimental setup consisted of 2 recording sessions per participant. One earlier in the morning, which was labeled as the alert session, and one later in the afternoon before participants returned home for the day, which was labeled as the drowsy session. During each recording session, participants had to go through 3 main recording steps. The baseline, where they just seated as we recorded their signals without any interaction taking place, and these data were then used as normalization signals for each individual. The free driving section, where they were free to drive without following any specific instructions in a simulated environment for approximately 15 minutes, and the distraction section, where they had to engage into 4 different driving distractions which aim to simulate common distractions in driving. Particularly, the distractions were texting and driving, an auditory version of the NBAC test, which is a popular test in psychiatry to evaluate short-term memory. In particular, in this distractor, the participants had to listen to a sequence of letters while driving, and if they heard the same letter twice consecutively, they had to repeat the letter loudly. Then it was the emotional radio distractor, where they had to listen to a recording that was emotionally intense while driving and then express their thoughts and feelings on what they just heard. And lastly, it was the GPS distractor, where they had to verbally interact with a faulty GPS that was giving constantly the wrong instructions, causing stress and frustration to the participant. Our analysis presented in this work focuses exclusively on the visual and physiological modalities. In particular, we perform an action unit analysis and physiological feature analysis, and we take a closer look on how different features are associated with different distractors. Our findings showed that the most indicative action units with respect to distracted behavior are action units 5, 10, 6, 23, and 1, while physiological features describing the heart's interbeat intervals and the low and high frequencies of the blood volume pulse signal were of most importance. With respect to classification results, physiological modalities proved to be more robust on both detecting and characterizing the different distractors, while combining the 2 modalities led most often to the best results. Regarding the drowsiness detection task, we focus more on analyzing the different physiological signals. As we can see from the results, this proved to be a relatively more challenging task. Overall, processing just the raw data from the available signals led to the best results, while BVP and respiration-related data and features showed progress in behaviors when processed individually. Even though we have a couple of works that are pending for publication on this topic, this still remains a challenging problem, and more analysis has to be done in order to have more concrete outcomes. Thank you.